Hello everyone, my name is Hyun-San. I'm going to talk about ceramide for therapeutic agents and topical applications. Firstly, I'm going to start with skin and ceramide. The human skin should protect the organism from various pollutants such as sunlight or stimulation. The skin is composed of three layers: the epidermis, dermis, and subcutaneous fat. The outermost layer of the epidermis, the stratum corneum, is composed of corneocytes and skin lipids that glue them together. It is also called the brick-mortar structure, with corneocytes as the brick and lipids as the mortar. Skin lipids form a lamellar structure by mixing ceramides, fatty acids, and cholesterol in appropriate proportions. Ceramides are one of the most abundant components of skin lipids and play an important role in the skin barrier function, protecting the skin from external stimulation and maintaining moisture. So, changes in the ceramide content of the stratum corneum are associated with numerous skin disorders. When ceramides are reduced in the skin, the protective layer of lipids in the skin is disrupted. This causes increased transepidermal water loss. The structure of ceramides consists of a sphingosine base and an amide bond with a fatty acid with two tails. There are about 20 different types of ceramides, depending on the types of sphingosine and fatty acids. Among them, the group called ceramide NP exists most evidently in the actual skin barrier. Despite its contribution to skin barrier function, ceramide has some problems to be incorporated into cosmetic formulations. Due to their hydrophobic tails, they have a strong tendency to phase separate or form molecular crystals, which seriously hinders diversifying their formulations. After preparation for formulation, there is the precipitation of crystalline particles. Thus, viscosity also increases by gelling, making it difficult to apply for cosmetic formulations. It could be manipulated by varying the composition of lipids and the proper emulsification system for proper skin bioefficacy. In recent years, ceramides have been incorporated into conventional and novel carrier systems to apply ceramides to help the barrier function of the skin. So I'm going to introduce three applications for stabilizing ceramide. First one is about lipid vesicle. They report on a ceramide co-assembled lipid nanovesicle system that is designed to enhance the penetration of active ingredients through the skin barrier by taking advantage of molecular associations between ceramide and lipids in the stratum corneum layer. The crystallization of ceramide was successfully prevented by inducing molecular associations of ceramide with combined colloidal stabilizers, lestine and class 24. They showed that the system simultaneously improves skin barrier function and skin penetration through in vitro skin barrier recovery tests and confocal Raman spectroscopy. And next one is about ceramide liposomes for skin barrier recovery. The authors prepared stable ceramide liposomes based solely on natural skin lipids. Their main stabilizing agents were cholesterol, stearic acid, and urea, and they confirmed the high repair ability for disrupted skin after treatment. Last one is about ceramide particles. They introduced an approach for fabricating stable ceramide microparticles whose interface is structured with the membrane of hydrophobically modified bacterial cellulose nanofibrils. Co-assembly of ceramide with fatty alcohol enabled the formation of a multilamellar structure in the core of ceramide microparticles. They confirmed membrane structure using cryo-TEM, and the Maltese cross pattern, which can be observed from the clear lamar structure, was also confirmed by a polarized microscope. Additionally, using the porcine skin model, they evaluated the ex vivo recovery of skin barrier function. The test results of the ceramide particle dispersions were compared with those of ceramide NP dispersions prepared using twin 80 with the same lipid composition. Histological analysis confirmed that the epidermis treated with the ceramide particle becomes well-ordered, while more densely restoring the structural integrity of the epidermis. But there is no significant change in the negative control. As the concentration of ceramide NP increases, this histological difference becomes more pronounced. This observation implies that ceramide NP encapsulated in ceramide particles is more favorably delivered to the skin, making the skin lipids more organized. In my case, I'm researching the systematic study of detailed behaviors of ceramide molecules to stabilize the high content of ceramide. I'm starting to elucidate the binding mechanism and driving force of surfactants on the interface. I fabricated ceramide particles and I confirmed the enhanced absorption energy of cellulose surfactants depending on the crystallinity of the lipid interface, which is capable to stabilize ceramide in cosmetics. I hope these findings propose a significant approach to enhancing the skin barrier function by developing ceramide formulations. Thank you for listening.